In this session, we're going to look at how we can use VS Code and Claude Code for quant modeling. So this is essentially whenever we want to backtest strategies in terms of investing in things like the stock market. So rather than relying on maybe very informal rules or intuition, what we can do is we can test if any strategies have actually worked in the past and what that might mean then if we can apply them in future as well. As an example of this, I'm going to use a data set which is available online through what's called jkpfactors.com. And essentially they have set up a challenge or a leaderboard to allow users to test different strategies and compare their performance over the period 1990 to 2023. So this is the current leaderboard. At number 1, I have actually put together a strategy which has earned an annual return per year of about 27.88% compared to a volatility of 10%. And then also at number 5 is a strategy I've put together which is a linear processes in terms of asset pricing and how we can then select between those. So what I'm going to do in the session today is walk through how you can implement something similar to the strategy which is coming in here in number 5. There's a Sharpe ratio of about 1.5. That means an annual return of about 15% compared to a volatility of 10%. It's quite a simple strategy, but it can be very effective. So we'll see how you can do that. And then once you understand those fundamentals, you can build on it yourself and you can implement any other strategy that you might want to. As with all of our sessions, the key criteria to begin with is that you have installed both VS Code and the Claude Code extension within that. If you haven't done so, go back to the very first video in the series, which will talk you through how to download and how to connect up with the Claude AI system. You'll also be using Python right throughout this session. If you already have that installed, that will be found automatically. If you're just jumping in to this session, go back now and just download Python from python.org and ensure that you have that installed. In this particular session, we're also going to be accessing large volumes of data through a system called WRDS. Now, this gives you extremely high quality data and it is only available to people who have subscribed usually through their university accounts. But anyone who is studying at Queen's University Belfast will be able to do this and walk through it. For anyone outside of that, if you are at any other university, it might be possible, but otherwise probably will not be feasible. But for anyone for which this account will work, you can access it through the link given there. Once you set up your account, just copy your username and your password to the template file, which is included in your project folder, and I'll show you how to do that in just a moment. So we also then need to download the relevant files. These are all available on Canvas. If you go into the AI for Finance module and go down to the section about quant modeling, so we have several files here, and one of them, the main one, is going to be around a prompt that we will provide to the AI. And then we have some support scripts just to automate some of the process. So there's a template file which will just give you the details about how to download the data that we need. And then we have some files around the baseline strategy that I have put together. We can use that to begin with, and then you'll very easily be able to edit that and to adjust it in whatever way that you think best. So once you've got those files from Canvas, just download them onto your PC into one particular folder. So VS Code relies on folders, so make sure that these files are on their own in a single folder with no other files alongside them. Once you've done that, just go into VS Code, go to File and Open Folder, choose where you have just saved those files to. And the first thing we're going to do is just to put together our password details for this WRDS account. So click on .txt. In the middle window then, that will load up the file. And what you want to do is just to put in your username and password that you have signed up with through WRDS. So once you have that done, then that will allow Claude and the Python system to basically connect up your account to download the data. That makes it much easier for you going forward. Okay, so then click on 01 prompt quant modeling.txt. And this is the main file that we will use to drive the whole system. So read through the prompt, get some sense about what it does. So this is just the top of it, just giving you some background requirements. So you need to have Python installed, as I mentioned. You'll also need particular packages within Python that the AI can help you with if you haven't already got those. We will need these data sets. These are provided through the WRDS system. If you're using this for the first time, then this helper script in terms of download jkpdata.py will automate the download process for you. Or once you have them downloaded and you maybe want to edit them and you're coming back to them later, then we can just use those files which you've downloaded. For getting set up and to download the files, then you do need to have your WRDS credentials, so that password and username that we just talked through there. So you can also look through the rest of that prompt file. It provides several steps. Just to talk through those briefly. So as well as the installation requirements, the next step then is that the prompt tells the AI to download the data from WRDS. Then it works through this baseline strategy that I have put together. So essentially this builds on many decades of academic finance research, which looks at factor analysis. And essentially what this does, it takes all of the stocks listed on the stock market and it breaks them down by different characteristics. For example, what is their size? Maybe what are their pricing ratios? How much profit have they made? And for this particular data set that we downloaded, there's over 400 different characteristics which have been produced. What we get the prompt to do then is to work through each of those 400 different variables. And for each of them, we're going to work out how those types of companies have performed in the past. So maybe we find that smaller companies perform better. We maybe find that companies which are value firms compare better than growth firms. And that type of analysis gets performed across all 400 different characteristics. Then what we want to be able to do is to compare across all 400 and work out which of them actually matter. So many of them will be irrelevant. They won't create any additional profit whatsoever. So they can be ignored. Others will work better at different times. And what we want to do is to develop a portfolio which is going to get the best possible outcome. Now, one of the key issues is that we need to be careful about what's called look-ahead bias. So the setup ensures that all of these calculations are done on just what has happened up until that point. So it's just using information available at a particular time and works its way through and makes judgments and predictions about what might happen next through that process. Then it will run the analysis. It evaluates the performance of the strategy from 1990 to 2023. So we have a 30-year period to analyze, does this strategy actually work? And then it's going to provide the outputs required for submission. And you will be able then to actually go and submit your work to this global leaderboard yourself and see how your performance compares. Okay, so once you've looked through the prompt and understood some of the concepts, and you can also look at some of those other support files as well, what we can do then is just to open up Claude Code. So click on the little orange icon at the top of the file. This will open up a Claude Code sidebar for us. We're just going to close down the additional chat window, which is embedded within VS Code. It's not needed at this moment, so we'll just simplify our screen slightly. Within Claude Code, then we're going to make sure that we have the correct settings. So the first thing we want to do is to click on the little button with a little slash on it, and we're going to choose the model to be Opus, and the effort equal to high. So this is a very strong model. Has recently been announced another model called Fable, but it is still excellent and uses less tokens, and you can get more usage from it. We're also then going to select auto mode. So what this will do, it prevents Claude Code from continually checking for permissions from us, and it automates most of that process. Okay, so once we've that set up, all we need to do now to begin running the analysis is to just type into Claude Code that we want to implement 01 prompt quantmodeling.txt. And Claude will read through that prompt file. It will also look through the other helper files that we've put together. And from that, it will run through the entire process for us. Now, this can take quite a long time. So especially when you're downloading data for the first time, that can be a very lengthy process. So it might take 30 minutes, for example, just to get the data. Then it will step through all of those various processes within the strategy. So it will sort all of our stocks according to different characteristics. It will work out the portfolios and it will weight them. And then it will output the requirements for you to then be able to submit your model to this jkpfactors.com leaderboard. After that has completed, and that might take 30 minutes, it might take even longer, you will get some output confirming what we've got here. So what it does, it calculates the Sharpe ratio, which is basically the return which we earn from our portfolio, minus the risk-free rate, so what you would earn from something like maybe government bonds, and it scales that and compares it to volatility. So the Sharpe ratio, the key number that we have at the bottom here is that from 1990 to 2023, this model is producing a Sharpe ratio of 1638. Now you can see that it varies quite a bit between different time periods. In the early period, before when we actually want to focus on, the Sharpe ratio was even higher at 2.5. From 1990 to 2003, it did even better at 3.0, and it has degraded quite a bit in between times. So 2004 to 2011, 2013, and from 2014 to 2023. They're still good positive Sharpe ratios, but lower than they have previously. And this is something that we find right across asset pricing, that in recent decades, it's actually increasingly difficult to find these excess returns. So one of your challenges will be then to try and get as much extra output from that as you can do. So the key result in terms of the leaderboard, at least, is for the Sharpe ratio of 1.638. Now, if we then look through the files that have been generated, so there's quite a lot of work has been done here by the AI system. So from our original several files, it has generated several others. It has downloaded the large data sets into what's called Parquet files, and it has also put together other Python files to help it with the calculations. Now, what we need to do is just double click on the submission folder at the top of that, and that will then open up another subfolder. Within that, we then have details about what we need for submission to this JKP factors competition. So we have a methodology file. Read through that carefully to understand exactly the approach that has been taken in this baseline strategy. We then have our Python strategy file, which is what can be used to recreate this. So once we upload this, anyone will be able to implement the same strategy. And then our weights.csv file is a calculation showing all of the different weights that we would allocate to each stock in the stock market over this 30-year period. Each month, how much would we have invested in it? If we look at the leaderboard that has been put together globally here, so we are finding the Sharpe ratio of about 1.63. That is actually going to put you into 5th place in that leaderboard. So if you go ahead and just use the baseline file, you will already be into the top 5. What I would like you to do is then to go even further. So ask Claude for other adjustments to the strategy, which hopefully is going to maximize the Sharpe ratio further. Now, the first attempt you make might not improve it, the second attempt might not improve it, but if you keep working through and try different strategies, come up with your own ideas using different theories that we maybe discussed in lectures, hopefully then you'll be able to find even better outcomes. You can also look at the leaderboard, which is currently available online. It provides the Python files for all of the different submissions. So what you can also do is to look at the number one strategy. So this is a strategy I have put together, which is based on academic research published very recently by Kelly et al., which looks at how we can use what's called nonlinear portfolio transformers. So you can also download that Python code and you can ask AI about how to implement that and how you can then advance in it further. So once you've tried some different strategies and you've come up with your own approach, you can then upload the output onto Canvas as part of the assignment. And then you can also upload all of this to this global leaderboard, and you can demonstrate to employers that you have been able to work through a very detailed asset pricing quant modeling technique, and you can then use that as a basis going forward. From there, you can then hopefully build on this quant modeling in lots of different ways, use your own ideas and techniques, which will help you then to advance in your careers.